Hello viewers, in this video we'll go through A-level further maths. This is component 1 pure maths 1 from May-June 2025 series variant 1. We'll attempt question 6 in this video. This one is a linear algebra question. It's given us 3 vectors in 3 dimensions and they want us to find or given that this all 3 lie on the same plane and they want us to find the equation of the plane in this form. Right, so maybe I can try and sketch it out. So it's just a sketch, so it's not so nice, but you can try and imagine what the plane looks like. If you go given the ABC, it will look something like that. We have 3 points. So the procedure to find the equation of a plane, first we find a normal vector, right? So or maybe I use a blue color for normal vector. So this is a n from the plane, so that once we have this normal vector, we can do the dot product on an arbitrary point of the plane or arbitrary vector on the plane, so that we can find, or we know that the dot product with this normal and the arbitrary point on the plane will be 0, and from that we can find the equation of the plane. And how do we find the normal? First of all, we use the cross product. So normal, we cross any 2 points or any 2 vectors on the plane. So any 2 vectors, you can choose BC, AB or AC, anyone. And then after that, we know that the normal, we multiply some, or we dot with some arbitrary vector, maybe given x is a point x, y, z on the plane. And so we multiply by, or dot with ax, so that we know that will be equals to 0. Okay, so let's first we start to find the normal vector. So we do the cross product, or maybe let's find AB and BC first. AB, so this should be simple, so it'll be B minus A. I will use the column vector notation. So the normal vector, you do the dot or cross product, cross these two. So you know cross product will be giving you a normal vector in from that direction. So I'll use the determinant method. I think there's another method where you have the I, J, K, then you do the multiplication. So that one I'm not sure how to do, so I'll usually use the determinant method. So 0, 2, 4, 1, minus 1, 1. For the I component, we cover the row and the column. So we 2, okay, cross multiply 2, and then from the bottom up multiply -4. So you add 2 minus -4. So you get 6. Next, for the J component, cover the row, the column, 0 minus 4. So we -4, but for J, due to the power of the matrix, you have to put the negative or multiply by negative again. So we get +4. Last, for K, again cover the row, the column, 0 minus 2. Okay, so for this normal vector, we don't really care about the magnitude as long as we have the same direction. So you can even simplify it to be 3, 2, -1. So we can make our calculation a bit easier. Or you can just leave it as 6, 4, -2 is fine also. Now we go for, we let x equals to xyz to be an arbitrary point on the plane. Okay, so we let just this is any point on the plane, and so we know that, let's say ax, that will be x minus 1, y, and z plus 2. And since this lies on the plane, we take the normal vector dot ax, that will equals to 0. And how we're going to do this? That's why okay, 3, 2, -1, right? And that's a normal vector, dot with x minus 1, y, z plus 2. So column vector for dot product is a bit easier to see, so we can just multiply horizontally. 3 multiply x minus 1, so 3x minus 3, 2y plus 2y, and then minus z minus 2. then equals 0. Then rearrange a bit, 3x plus 2y minus z equals to 5. And so this will be your equation of plane. So this plane, that's the equation. Okay. Point D has vector I plus tk, where t is not -2. And find the acute angle between plane AB and ABD. So maybe I just sketch what this looks like. So orange and I plus tk, right? So I we know is on here, and t, okay, t is we don't know what it is. So it can lie on any of these points. So it's a vertical, or it can lie anywhere here lah. This is D, possible values of D. So you want to find the acute angle between planes ABC and ABD. So just now we already found the normal of ABC. So let's find the normal of ABD. So let's just give an arbitrary point D here lah, let's say, just for the sake of comparison. And then maybe if the plane ABD, something like that, you'll find another normal vector. So maybe n2. So all we need to do is then do the dot product on these two, and then we can equate. Can use the formula sheet here. Where's the dot product? Down here. Okay, we do the dot product, and then you can equate with this cosine theta with the magnitudes, so that you can solve for the theta value. Okay, so this n and n2. So ABD. Okay, so first let's find AD, right? We got AB, then let's find AD also. AD. So there'll be D minus A. 0, 0, t plus 2. So n2, that will be, we can get this by crossing AB and AD. 2t plus 4. J cover, you have 0, and K, yeah, you also get 0. So given how do we solve this, since the t is unknown, right? But that doesn't really matter because we only want the direction of this normal vector. So no matter what the value of t is, you will still be only moving in the I direction. So we don't really care about what the t is. Because the other components are 0, so we can just take it this direction just to be in the I direction. Okay, so that's n2. And alright, so we can do this n multiply dot n2, not multiply. That will be equals to the magnitude of n multiply magnitude of n2 multiplied by cosine theta. So n was what already? N 3, 2, -1, n2 1, 0, 0. So that is, again, that's just the direction. So we don't care about the magnitude. And magnitude of n, so 3 squared plus 2 squared plus 1, that is 3 squared, 2 squared, 1, 14. Square root 14. And n2, yeah, that is just 1. Multiplied cosine theta. Alright, this dot product is very easy. So it's just 3 times 1, that's 3. Solving, you just type your calculator, theta, you should be able to get 36.7 degrees. Okay, so it doesn't matter, you give your answer in degree or radian. You did not specify, I believe. Alright. Now part C. Find the value of t such that the shortest distance between lines AB and CD is square root 2. Okay, so again, we know that D can lie on any, or it can exist on any of this orange line. So again, just for the sake of example, let's say this is D here. So CD, this line looks something like that. So they are not parallel. So we know that the shortest line between AB and CD, we want to solve for that case where it equals to square root 2. So maybe if there's a line here, and that line is the magnitude is square root 2. Okay, the line between CD and AB. Okay, so first of all, we want to find, or the shortest line would definitely be a perpendicular to this. So we want to find the perpendicular or normal vector. So we cross them again. So cross AB, CD. Do we have CD? Um, so we don't have CD. Let's find CD first. Then AB we have also. Okay, so AB cross CD. We can do that now. IJK024 -1 1 t plus 1. Cover t 2t plus 2 minus 4. That's 2t minus 2. J, okay, 0 minus 4. So that's minus -4. So that's positive 4. Then you have to multiply a negative again because it's a j. Lastly, k minus -2. So that's positive 2. And we don't care about the magnitude. So we simplify it to be this one. So yeah, we only want the direction, so this is the same direction, so the magnitude doesn't really matter. And what we want to find again, okay, now we have the cross, we have the perpendicular already, so we want to find from A to C what is the direction, like AC, which we already found previously. That is 1 minus 1 1, 1 minus 1 1. Okay, so we have the perpendicular direction, then we also have the current direction, which is AC. So when we dot these two, we'll get the contribution of AC to the perpendicular direction, which is the which is the shortest distance. And what we want to find is when we want to solve it for when the distance is actually square root 2. So what we will do is first we multiply, or not multiply, sorry, we dot these two. So the dot product is commutative, so we don't really care about order. Okay, so the dot already, we divide it by the magnitude of which one? Of the perpendicular. Okay, we divide it by the magnitude of the perpendicular line. And we equate this to be square root 2 because that's what we want. We want it to be square root 2. We divide it by the perpendicular magnitude, so there is a unit vector, then we equate it to -2. Okay, so let's try and solve this. So dot product can for column vector just multiply it horizontally. So okay, you should be able to get this quadratic expression. This equation won't be factorable. So you can type in your calculator or use the quadratic equation to get the two values of t is 6.83 or 1.17. So is there any restriction? No, no restriction, right, on t. As long as it's not -2, which they are not. And so this will be two of our final answers. So that is, I think that's the entire question 6. And thanks for watching.